Hi, I'm Varsha,
And I'm Devina.
and we're excited to share with you some new features we added to our first project in CS61B. When Devina and I finished up Project Zero, we started playing with some of the example text files given to us from the original lab skeleton files.
As we tried running our NBody main method on different universes, we noticed lots of collisions and realized we could make a game out of it. The first idea we had was for a one-player game with the objective of getting from point A to point B without colliding with any of the other objects in the universe. We successfully created a keyboard-controlled main player using KeyListener, JFrame, and other related Java classes. But quickly, we realized that meshing our code with our current Project Zero would be an implementational nightmare, especially in the short time frame. So sadly, we scrapped our main player idea and focused instead on refining the collision detection and graphics.
After exploring ways to implement collision detection, such as entities or creating different object types, we settled on a location-based function with the goal of emphasizing when objects in the universe collided with others. We defined a collision method that looks at the x and y positions of two objects and returns a Boolean value based on whether their distance is within a radius determined by the user. Using the terminal to establish the distance allows the margin between objects in the universe to be specifically catered to whatever is being simulated. For example, you might consider a new driver entering within a foot of a traffic cone to be a collision, or you may want collisions to be loosely defined, such as when a meteor shower enters the Earth's atmosphere but doesn't destabilize the planet.
Some of the modifications we made to the original NBody and Body classes include updating the NBody main method to take in another argument from the terminal, creating a static variable, and drawing new graphics on the screen. The static variable we created in the Body class, called collision radius, has a default double value that determines how close objects must be to each other to be considered a collision. The variable can be updated when a user calls it from the Body class and assigns it to a new value, or, as in our case, the variable is called from the main method of the NBody class and reassigned to the value inputted into the terminal.
The added argument and static variable combination also eliminates the need to write in an acceptable collision radius for every single object in the universe, which would require editing all the rows of each text file the program runs on. Finally, our new program displays an icon at each place of contact and slows down the graphic visualization to further highlight the impact. We chose to indicate the collision site with a cute "it's a trap" GIF. While the freeze frame currently implemented may not be optimal for all scenarios, we really like the visual effect of calling the pause method from the standard draw class after displaying the "it's a trap" GIF, so we kept it. You can easily remove the freeze effect by deleting just a single line of code.
Our program can be incorporated into a number of cool applications. The collision identifier can be helpful in simulations of flight control, chemical reactors, space travel, game development, and so much more.
Currently, the NBody and Body classes set the size of the visual graphics based on the mass of the object. Given just a little more time, my partner and I would have liked to revamp this to set the size of the objects based on radius length, which we could use to further refine collisions to use the edge of the objects within the universe rather than their centers. We would have also incorporated a few more basic physics equations into the update method to make the collisions inelastic and set the resulting velocities of the objects accordingly. Finally, we would like to put together all the pieces of a user-controlled player and collision detection into a fully developed game. The object of the game would be to catch the shooting star before colliding with 3 other objects and subsequently ending the game.
Now we will run a few of our simulations. As you can see, there is another parameter that we introduce when running the main method. This is the radius we chose that would determine whether there is a collision or not. There are 3 text files we will show that display this collision detection.
Thank you for listening to our Project Zero Extras. We hope you enjoyed and get a chance to test out our program yourself. Have a great day!